Next question is, let P equals to 1, 2, 3, 5, 7 and Q equals to 0, 4, 7, 9. Write the ordered pair set such that P minus Q is an odd whole number. Everywhere condition is different, and I have tried to collect as many different questions as possible based on the relation. It is very important to understand the relation properly. Given P equals to 1, 2, 3, 5, 7 and Q equals to 0, 4, 7, 9. So we have to find out odd whole number. We have to find out the difference is odd whole number. So we have to check the same way. We have to check one by one. One is compared with all 0, 4, 7, 9. Now 1 minus 0. 1 minus 0 is 1. Is this odd? Yes. 1 minus 4 is minus 3. Yes, but it is negative odd. But we have to check whether the number is odd whole number or not. So it will not satisfy. 1 minus 7 is minus 6. Again it is not. 1 minus 9 is minus 8. Again it is not. Only one condition, that is 1 is an odd number, whole number, while minus 3 is an odd integer, and minus 6 and minus 8 are also integers, but they are even, that is fine, but they are not whole numbers. So only 1 and 0 satisfies. Next is 2 compared with 2 is compared with 0, 4, 7, 8. 2 is compared with all. Again 2 minus 0 and 2 minus 4. 2 minus 0 and 2 minus 4 is minus 2. This is even number. This is integer. This is odd number but integer. This is again integer. So again we have no condition, no two elements satisfy the given condition, so none satisfies the thing. Next is to compare 3 then. 3 is compared with all of them. 3 minus 0, let's check. 3 minus 0 is 3. Yes, it is odd number. 3 minus 4 is minus 1. Integer, no. Minus 4. 3 minus 7 is minus 4. It is again no. 3 minus 9 is minus 6. Again it is not. So only 3 is an odd whole number. It satisfies, this one only satisfies. So we have ordered pair 3, 0 as the one which satisfies the relation. Next element is 5 compared with all 0, 4, 7, 9. So when 5 is compared, 5 minus 0, 5 minus 0 is 5. Yes, it is odd also. For 5 minus 4 is 1. Again odd number. 5 minus 7 is minus 2. No. 5 minus 9 is minus 4. Again no. So 5, 0, 5, 0 and 5, 4 are the two ordered pair that satisfy the relation. Next, 7 is compared with all. Now 7 is compared. 7 minus 0 is 7. 7 minus 4 is 3. So this is true condition. This is also true condition. 7 minus 7 0. No, it is not. It is not an odd number. It is whole number, but it is not an odd number. This is an integer. So only 7 0, 7 4 are satisfying. So relation ordered pair, set of all the ordered pair would be 1 0, 3 0 and 5 0, 5 4, 7 0, 7 4, 5 0, 7 4. These are all ordered pair of the ordered set. If A is 2 4 8 16 and C is 1 4 8 16, then find the relation from A to C such that A divides C and A is less than C. So we have two conditions here, that A is dividing C also and A is less than C also. So let's see. A is this and C is this. So let's check out our first element with rest of them like that. So 2 is compared with 1, 4, 8, 16. When we are comparing, then 2 divides 1 will give us 1 by 2. 2 divides 4 will give us 2. 2 divides 4 will give us 4 by 2, which is 2. So next is 2 divides 8 will give us 4. 2 divided 16 will give us 8. So we can see that, and we have two conditions, that it should be divide also and it should be less than also. So we have to check what are dividing. So we have 2 4 dividing, 2 8 dividing, and 2 16 dividing, and we have to check whether they are less or not. So 2 4 is less than, 2 is less than 4, 2 is less than 8, 2 is less than 16. So these three will belongs to R. That means 2 R 4, 2 R 6, 2 R 16. Next, 4 is compared with 1, 4, 8, 16. We have to check again. So 4 is divides 1. If 4 divides 1, then 1 by 4. No, our condition is not satisfied. 4 divides 4, it gives us 1. Yes. 4 divides 8 is 2. 4 divides 16 is 4 again. So we have three conditions where our first condition satisfied. So 4 is less than 8. Yes. 4 is less than 16. Yes. 4 is not less, 4 is not less than 4. So our first we have to leave. 4 4 we cannot take, but 4 8 and 4 16 we can take as a part of a relation, given relation. Now 8 is compared with 1 4 8 16. So 8 divides 1 gives us 1 by 8. 8 divides 4 gives us 1 by 2. 8 divides 8 will give us 1, and 8 divides 16 will give us 2. So these two are satisfying. That means, but 8 is equal to 8, so we cannot take this, and 8 is less than 16. If 8 is less than 16, are both the conditions satisfied. That means 8 16 belongs to R. Last element 16 is compared with 1 4 8 16. So 16 divides 1, 1 by 16. 16 divides 4 is 1 by 4. 16 divides 8 is 1 by 2. And 16 divides 16 is 1. This condition, this is dividing, but 16 is not less than 16. Hence, none of the ordered pair will be added. So our final sets ordered pair in the relation are 2 4, 2 8, 2 16, 4 8, 4 16, 8 16. So these are the things. This 4 8, 4 16, 8 16, and that's it. 8 16 is the last one. So this is how we have to check when two conditions are given. Formulate R where A equals to 1 2 3 4 5 and R equals to AB, such that A belongs to A and B belongs to A. See, here A also belongs to set A and B also belongs to set A. That means given A set will be equals to set B also. And the next condition is A divides B. A divides B is the thing, and the twist was here that A belongs to A and AB both belongs to A. So let's check out the first element. First element compared with 1 2 3 4 again. So 1 dividing, 1 can divide 1 2 3 4 5. So 1 can divide all. So all the pair, all the ordered pair can be, will be part of relation. 1 1 1 2 1 3 1 4 1 5. They are. Next, 2 is compared with the rest of them. 2 cannot divide 1 or 5. So 2 divides 2 and 4. So 2 4 belongs to R. Now 3 is compared with the same way. 3 is compared with all. Achha, 1 2 3 4 and 5. So when 3 is compared, only none of them. Okay. 3 is compared to the same set, then only 3 will be divisible. So 3 divides 3, that means only 3 3 belongs to the relation. Next is 4. 4 is again 4 only divides 4, hence 4 4 belongs to R, and 5 also divides 5 only. So 5 5 belongs to R. Hence R is the set of all the ordered pairs 1 1, 1 1, 1 2, 1 3, 1 4, 1 5, 2 2, 2 4, 3 3, 4 4, 5 5. Next question is, let A be the set of first 5 multiples of 5 that ends with 5, and B is the set of first 5 composite number. So there's a question inside, the set is not given, we have to formulate set also. And which of the following represent a relation are A from A to B? So first, in order to solve any question, we have to formulate sets first, because the set is not given directly. So first condition says first 5 multiples of 5. So first 5 multiples of 5 means that ends with 5. Okay, that ends with 5 means 5, 15, 25, 35, 45. And first 5 composite number will be what? 4, 6, 8, 9 and 10. So now we have the set A equals to 5, 15, 25, 35, 45 and B as 4, 6, 8, 9, 10. So first question is R equals to 5, 4, 5, 10, 15, 45, 5, 4, 5, 10, 15, 45 and 35. So let's check it out with the help of arrow diagram. So what is happening? A is here, B is here, we have AB. Now the relation is 5, 4. So relation is 5, 4. That means 5, 4 and 5, 10, 15 and 45, 35 and 10. These are related. We know the definition. According to the definition, element of the same set cannot be related to the same set element. So we have to see 15 and 45. 15 and 45 does not satisfy a relation uh, definition. So it is not relation. But let's check out other ordered pairs. 5, 4. Yes, 5, 4. 5, 4 is yes. 5, 10 is also there. It is related. 35, 10 is also there. So, but 15 and 45 can't be possible. They cannot be possible. If they are not possible, that means it is not a relation. So we have to check each and every ordered pair whether they are related or not. Here, 5 related to 4, 5 related to 10, 15 is not related to 45 and 35 is related to 10. Even only one condition is false, still this is not a relation. So we have to be very careful about checking the relation. Next is relation 5, 8, 5, 9, 15, 10, 35, 10, 45, 4. Let's see it further. Now, 5 is related to, let's check. This is the arrow diagram. This is the best way to represent this. Now, 5, 10, 25, 35, 45, these are all marked up here. And 4, 8, 6, 8, 9, 10, they are marked on the right side. So we have to check. 5 is related to 8, 5 is related to 9, 15 is related to 10, 25, 35 is related to 10 again, and 45 is related to 4. So all are related to something. And there is no within the set relation, right? There is no such relation. So that means we can say that these ordered pair represents a relation. Let's move further now. Find the domain and range of R if x, y such that y equals to 2x plus 3. So 2x plus 3 when x belongs to R. So condition is y equals to 2x plus 3. So y equals to 2x plus 3 and x value. The x value is nothing but domain. So domain is given directly. So domain is minus 5 less than equal to x is less than equals to 5. So here less than equals to is nothing but closed interval. Equal to and equal also, less than also or equal also. So whatever value will be here, this is the value. That means minus 5, minus 4, minus 3, minus 2, minus 2, minus 1, 0, 1, 2, 3, 4. and 5 also, obviously. So these are all values for x or domain. So you can see that domain is nothing but this. If this x belongs to R is a real number here. You have to be very careful here. R1, here it should be R1. So that we can distinguish this real value, real number and relation R1. Both are different. This R and that R1 is they are different because R1 represents relation and R represents real value, real numbers. So if it is real number, that's why we can include minus value and something. If it be whole number, then the answer would be 0 and 5. So we have to be careful about the conditions. Now we have to formulate for range. We have to formulate the range. How come? Like we know that x belongs to minus 5 5. So x, what we do, we multiply. We need what? 2x plus 3 we need in order to make y. Y's value is nothing but range. Y's value is nothing but range. We'll be studying in detail in the next topic, functions properly. Let's see for now. Let's solve this question. So let's multiply 2x because here is our y value is y equals to 2x plus 3. So we are trying to make left side as 2x plus 3. So x belongs to minus 5 5. 2x belongs to 2 into minus 5 5. So plus 3 is also there. Y equals to plus 3. So y equals to plus 3, that means we'll add plus 3 also here. So plus 3 here also plus 3. So 2 into minus 5 gives minus 10. 2 into 5 gives 10. Plus 3 as it is. Now it gives us minus 10 plus 3 gives minus 7 and plus 10 plus 3 gives 30. So y belongs to minus 7 and 30. So range is minus 7 and 30. Should we do it again? Here we have to find out domain and range. Domain, we can see that x value of x belongs to minus 5. It's less than or equal to minus 5 and greater than equals to minus 5 and less than equals to plus 5. So that means the value of x is between minus 5 and plus 5. Minus 5 and plus 5. This is the x value given. If it is 0 and this is plus 5 and this is minus 5, then a value of x is between these two fives. These two fives. So question is whether to include this value or not. So this is called as closed circle, closed interval. Closed interval is why? Because this is equal. When we say it as closed circle, when we write it at like this, that's called as open interval. If it would be minus 5 less than x less than 5, then the interval would be minus 5 and 5. It's like that. That means what? What is the difference between closed interval and open interval? So it will not include the extreme values. It will leave these two values and then take all the rest of the values. That means minus 4, minus 3, minus 2 till plus 4. That's it. 5 and minus 5 will not be included if it would be open. Open means equal to sign is not there. That's called as open. So we'll be studying about the types of intervals soon. So here it is minus 5 and 5 because the value x value is between minus 5 and plus 5. Now we know that x belongs to minus 5 and 5. So we try to make this as 2x plus 3 so that we can get y. If we'll get y, we'll get our answer because the range is nothing but y. So 2x, we multiplied 2 first, then we added 3 first, 3 then. So when we added, this is the final answer. So minus 10 plus 7 plus 10 plus 3, like that. Minus 10 plus 3, sorry, and plus 10 plus 3. So minus 10 plus 3 will give us minus 7 and 10 plus 3 gives us 19. So minus 7 and 13 close interval value is range, or range in this particular question. Let's move on to next question. Let a equals to x belongs to whole number and x is less than 3, and b equals to x belongs to natural number such that x belongs to 1 and 5. See, it is here closed interval and here it is open interval. So when open interval we talk about, we don't include this value. We don't include the range, the limit, whatever value is here. So if it is 5 here, we will not include 5. Let's see. So x belongs to w. W is a whole number when x is less than 3. It's an open interval. It's an open interval. So when it is open interval, then obviously it's w. Then it will start from 0, 1, 2, 3, and 3. There is open interval. If it is open interval, we don't include it. Then we take. Then the value would be 0, 1, or 2. 0, 1, or 2 values. Similarly here, then it's natural number. 1 is closed interval. It's less than equal to. That means 1 will include. So we have included 1, 2, 3, and 4. 5 is 5 we are not included. Why? Because there is an open interval there. 1, 2, 3, 4, 5. But 5 here there is open interval, and on 1 it is closed interval. Closed interval we denote it by dark circle, and open, it's a open circle. So B is like that. So Cartesian product of A and B we can find out easily now. 0, 1, 0, 2, 0, 3, 0, 4. Basically first element with all, then second element with all, and third element with all. So this is a final Cartesian product.